It is late, the room is dark, your body is exhausted, every single condition for sleep has been met. The temperature is right, the lights are off, the pillow is comfortable. You have nowhere to be for 8 full hours, and yet your brain, that 3-pound organ that supposedly exists to help you survive, has decided that right now, at this exact moment, is the perfect time to replay every embarrassing thing you have ever said, calculate every possible way tomorrow could go wrong, remind you of an argument you had in 2014 that you never properly resolved, and suddenly wonder whether you turned off the stove. You close your eyes. The thoughts get louder. You try to breathe slowly. The thoughts get faster. You tell yourself to stop thinking. And then you think about the fact that you are still thinking. And then you think about the fact that you are now thinking about thinking. And somewhere in that spiral, another hour disappears and the ceiling is still there and the dark is still there and you are still completely, infuriatingly awake. You are not broken. You are not anxious. You are not weak. You are doing something your ancestors did every single night for 2 million years. And understanding why they did it, and why you still cannot stop, will change the way you think about your own mind forever. Here is the thing nobody tells you. The version of you that lies awake overthinking at night is not the version of you that failed to relax. It is the version of you that is running one of the most sophisticated survival programs the human brain has ever developed. A program so old, so deeply wired into the architecture of your nervous system that no amount of meditation apps or white noise machines or warm milk or sleep podcasts has ever fully turned it off. Because it was never meant to be turned off. It was meant to keep you alive. Go back 100,000 years. Your ancestor is lying on the ground, or in a shallow cave, or up in a tree. The sun has gone down. The fire is burning low, and the world, from every direction, is full of things that want to kill them. Predators that hunt at night. Rival groups that move under cover of darkness. Snakes that cannot be seen until they are already coiled beside you. Spiders that drop from branches. Flash floods that come without warning from storms 2 valleys over. The 1,000 small catastrophes that the daylight hours made visible and the night made invisible again. Your ancestor could not afford to fully relax. Not completely. Not the way you relax when you are safe inside a locked house in a city with electric lights and a functioning immune system and a phone that can call for help in 30 seconds. For your ancestor, the transition from wakefulness to sleep was one of the most dangerous moments of every single day. The moment the brain went quiet was the moment the predator moved. The moment the rival crept closer. The moment the fire went out and the cold came in and nobody noticed until it was too late. And so the brain developed a system. A final check, a last sweep of everything that had happened that day, everything that was unresolved, everything that might go wrong before dawn. Not because the brain was malfunctioning, because the brain was doing exactly what it was built to do, running a threat assessment at the one moment of the day when threats were most likely to materialize and the body was least able to respond to them. That system is still running in you, tonight, right now, every time you try to sleep. Neuroscientist Matthew Walker, who spent decades studying sleep at the University of California, Berkeley, and wrote one of the most important books ever published on the science of sleep, describes the pre-sleep brain as being in a state of heightened vigilance that evolution has never fully resolved. The human brain, he argues, is uniquely vulnerable to what he calls the ruminative loop, the tendency to cycle through unresolved problems repeatedly at night, turning them over and over without ever reaching a conclusion because the unresolved problem at night once meant real physical danger. The brain that kept cycling, kept scanning, kept running scenarios was the brain that occasionally caught the thing the relaxed brain missed. And catching that thing sometimes meant the difference between waking up and not waking up at all. Now think about the old man. Not your grandfather, though perhaps him too. Think about the old man 10,000 generations back, the elder of the group, the one who had lived long enough to remember the last time the river flooded, the last time the strange animals came from the north, the last time the dry season lasted 2 months longer than it should have. He is lying in the dark with his family around him. The young ones are already asleep, but he is not. His brain is doing what old brains and old bodies do when the world goes dark. It is running. Reviewing. The argument with the neighboring group that ended badly and was not fully resolved. The child who has been coughing for 3 nights in a row, the route to the next water source, which will need to change when the season turns, the young man in the group who has been making decisions that worry him. All of it cycling through in the dark while his body lies still and his eyes stay closed and the rest of the group breathes slowly around him. That worrying was not a weakness. That worrying was leadership. That worrying was love expressed in the only language the ancient brain knows how to speak after the sun goes down. The old man who worried most was the old man whose group survived. His children had children who eventually had you. And you inherited his brain. You inherited his night. Anthropologist David Samson at the University of Toronto spent years studying sleep patterns in modern hunter-gatherer communities, the closest living approximation we have to the way your ancestors actually slept. What he found dismantled almost every assumption modern sleep science had been working with. Your ancestors did not sleep the way you sleep. They did not go to bed at a fixed hour, enter 8 hours of unbroken unconsciousness, and wake refreshed and ready. They slept in fragments, in shifts, in overlapping cycles of light sleep and brief wakefulness, with different members of the group in different stages of alertness at almost every moment of the night. Samson called this the Sentinel Hypothesis. The idea is simple and it is profound. In a group of sleeping humans, the evolutionary advantage goes to the group where someone is always at least partially awake, where the lightest sleepers wake at sounds, where the anxious ones lie half alert in the dark, scanning without knowing exactly what they are scanning for. The hypervigilant brain is not the broken brain. The hypervigilant brain is the sentinel, the one keeping watch while the others rest. And in a world where things moved at night and wanted to eat you, having a sentinel was the difference between a group that survived and a group that did not. Your 3 a.m. wide awakeness is not insomnia. It is your brain fulfilling an ancient role that kept your species alive through 2 million years of darkness. You are the sentinel. You are just doing it in a world that no longer requires it. But here is where it gets stranger, because the content of what your brain chooses to think about at night is not random. It follows a pattern, a very old, very specific pattern. Psychologist Antti Revonsuo at the University of Turku in Finland developed what he called the threat simulation theory. His argument was that the dreaming brain, and by extension the pre-sleep ruminating brain, is specifically and systematically biased toward negative and threatening scenarios. Not out of pessimism, not because something is wrong with you, but because the brain is rehearsing, running simulations of things that could go wrong so that if they do go wrong, you have already, in some neural sense, practiced responding to them. Think about what your brain actually does when you lie awake at night. It does not replay the good conversation you had last Tuesday. It does not run simulations of things going perfectly tomorrow. It replays the conversation where you said the wrong thing. It imagines the meeting tomorrow going badly. It plays out the argument in full detail, gives the other person's best counter-arguments, and then makes you respond to those counter-arguments too. It is thorough, it is relentless, and it is completely, from an evolutionary standpoint, rational. Every conversation you replay at night where you finally say the thing you should have said, every catastrophic scenario you run about tomorrow's presentation, every argument you silently prepare for, with someone who has no idea you are preparing for it. These are not signs of anxiety spiraling out of control. These are signs of a mind doing exactly what Revonsuo describes. Threat simulation, rehearsal for a world that is always, at some level, uncertain. A world where the wrong response to the wrong situation at the wrong moment could end everything. Your ancestors rehearsed the same way. Lying in the dark, listening to the sounds of the savannah or the forest or the river bank. Their brains were running scenarios. What if the sound comes from the east instead of the west? What if there are 2 of them? What if the food stores run out before the rains come? What if the elder is wrong about the route? What if the child does not recover? The brain that ran these scenarios most thoroughly was the brain that was most prepared when the scenarios stopped being hypothetical, when the sound did come from the east, when there were 2 of them. You inherited that brain. Every neuron in your prefrontal cortex that lights up when you stare at the ceiling at 2 a.m. rehearsing tomorrow's difficult conversation is the direct descendant of the neurons that kept your ancestors alive long enough to have children. That is worth something, even at 3 a.m. when it does not feel like it. But what do you actually do about it? Because understanding where the behavior comes from does not automatically make it stop. The sentinel is still watching. The old man is still running his calculations in the dark. And you still have to be at work in 5 hours. The research points to something counterintuitive. Fighting the thoughts makes them louder. Telling yourself to stop thinking activates the same mental processes that generate the thoughts in the first place. It is like trying to not think about a white bear. The moment you tell your brain what not to think about, that is exactly what it thinks about. What works, according to sleep researcher Alison Harvey at the University of California, Berkeley, is not suppression but engagement followed by release. Give the Sentinel what it needs. Write the list it is trying to build. Acknowledge the problem it is trying to solve. Put the unresolved thing somewhere outside your head, on paper, on a phone, anywhere that is not inside your skull, so that the part of your brain responsible for maintaining the alert can perceive that the information is stored and does not need to be held in active memory anymore. The Sentinel does not stop watching because you tell it to stop. It stops watching when it believes someone else is watching. When it trusts that the information it has been guarding is safe. Your ancestors did this too, in their own way. They talked around the fire before the fire went out. They named the worry, they shared the calculation, they handed the vigilance to the group so that no single brain had to hold all of it through the dark. The campfire conversation before sleep, the one that anthropologist Polly Wiesner found dominated by storytelling and social processing in modern hunter-gatherer groups, was not just entertainment. It was cognitive offloading. It was the group mind doing collectively what the individual brain would otherwise have to do alone, in the dark, for hours. You do not have a campfire, but you have a notebook. And the principle is the same. Externalize the thought. Name it. Record it. Trust that it will still be there in the morning when you are actually equipped to do something about it. And give the ancient sentinel inside your skull permission to stand down. Not because the world is safe, but because you have acknowledged the watch, because you have seen what it sees, because you are, in the language the old brain understands, aware. It is late. The room is dark. Your body is exhausted, and somewhere deep in the architecture of your mind, a version of you that has not slept soundly in 2 million years is still listening for the sound that never comes. Still running the calculations, still preparing for the danger that the darkness might be hiding. That is not a flaw. That is not anxiety. That is the oldest love story in the human record. Your brain, refusing to stop caring about whether you make it to morning. Refusing to let its guard down completely. Refusing to trust, even after all this time, even after all this safety, that the night is truly safe. The old man is still watching. He always will be, but tonight, you can tell him you already wrote it down. You already saw it, you already know, and for tonight at least that might just be enough.